So one of your colleagues asked me in which normal form is this table in, okay? And notice that I'm not, is not asking to normalize the table. The question is, what is the normal form of this table given these functional dependencies, okay? So how can we determine the normal form? First of all, we need to find what are the essential attributes of the table. And the essential attributes of the table are those attributes that cannot be found by other attributes. Okay? And in class we did this by creating like an edge diagram. Okay, let's do that again. So this will be the same, basically the same. Probably the functional dependencies are different, but the principles are all the same as we used in the classes. So let's start. So from A and C, I can find age. So from A and C, I can find age. So I have an incoming arrow to age from A and C. From B, I can find C and D. So from B, I can find C, and I can also find D. From C, I can find three attributes, D, G, and H. So from C, from this one, I can find D, I can find G, and H. Okay? And from B, I can find, from F, I can find B. So from F, I can find B. Finally, from G, I can find two attributes. So from G, I can find F and G. So F and H. So from G, I can find both F and I can find H. Okay? So the essential attributes are those that don't have an incoming edge, an incoming arrow. Okay, so A doesn't have any incoming arrow. So I'm gonna write it here. So A doesn't have incoming arrow, B has an incoming arrow, C has an incoming arrow, D has two incoming arrows, E doesn't have any incoming arrow, nor outgoing, so but what I care here is the incoming arrows. F has one incoming arrow, G has one incoming arrow, and H has three incoming arrows. So these are my essential attributes. If they are essential, they will need to be present in my key. Now, let's see if I can find all the attributes of the table by using only these two attributes, the essential attributes. Okay? So how do I do that? By calculating its closure. So from A and E, I can trivially find A and E. Yeah, if I'm giving A, I can find A, and if I'm giving E, I can find E. That's obvious. Yeah, I have it. Can I find anything else? So let's see. I have A and E. So I don't have A and C. Do I have B here? No, I don't. Do I have C? No, I have A and E. Do I have F? No. Do I have G? No. So from here I cannot go anywhere else. If I was able to find the whole table or the whole attributes by using the essential attributes, this would be my key for the table, my unique candidate key. Okay? So let's see if we can find the candidate key by candidate keys by using other attributes. I know that A and E must be present in the key because they are essential. Now I need to combine these with other attributes. So I'm not going to combine with A because I already have A, so with B. Okay? And let's find the closure of this key. So from here I can go to A because I'm given A, I can go to B because I'm given B, and I can go to E. So basically this is trivial and I just sorted the attributes. Now, here, do I have AC? No, I don't have AC. Do I have B? Well, yeah, I have B here. B can take me to C and D. So I have A already, and now B. And now from B, like it says here, I can go to C and D. So two new attributes, C and D. But I already had E, so let's keep E here. I'm going to start from the beginning. I always start from the top. So do I have A and C? Let's see. A, C. Well, I have A and C. Where can A and C take me? Can take me to H. So I have A, B, C, D, E, and now from AC I can go to H. So now I can reach H. Again from the top, well, we did this already, so this one is done. B can take me to C and D. Do I have B? Yes, but I already did that one too, so I already had C and D. And now that I have C, I can go to D, G, and H. So from C, I can go to D, G, and H. Well, I have D and H, but I didn't have G, so I'm going to add G. So A, B, C, D, E, G, and H. A, B, C, D, E, G, H. So this is the relation, yeah? No, it's not the relation. I'm still missing F. So can I get to F from anywhere? Let's see. F is here, yeah? So from G I can go to F. Do I have G here? Well, I do. So now I will have A, B, C, D, E, F, G, and H. And this is equal to my relation. Yeah, so I found the relation by these three attributes. So it means that this is a candidate key. Yeah, candidate key. Now I can have more candidate keys. It doesn't have to be only this one. Let's try AE. Now we tried with B. Let's try with C. Let's find a closure. So let's go here. Do I have AC here? Yeah, I do. I have A and C. So A and C takes me to H. So A, E. Well, let me sort. Put them sorted. So A, C, E. So this is trivial. Yeah. And now I can go to H. Okay, I could just sort it first and then go from there to this one, but it's all the same, just saving one step here. So now let's start from the top. Well, this one I did it. Let's go to B. Do I have B here? No. Do I have C? Yes, I do have C. So C takes me to D, G, and H. So A, C, now I can introduce D, and I'm going to put E, so it is sorted, and now G, H, G, and H. I already had H, but well, so I have to keep it. So starting from the top, AC, I already had that, did that one. B, I still don't have B. C, I just did it. And now let's go to F. Do I have F? Let's see. No, I don't have F. Do I have G? Yeah, I have G here. So from G I can go to F and H. So H I have, but I can insert F. So A, C, D, E, F, G, and H. The only thing that is missing now is B. A, B, C, D, E, F, G, H. Yeah. So can I go to B from any attribute? Yes. From F. Do I have F here? Let's see. I have F here. F takes me to B. So A, B, C, D, E, F, G, and H. So this is the relation, yeah, which means this is a candidate key, right? So I have one candidate key, I have another candidate key. Let's try with another. So AE with what? With D. So trivially takes me to A, D, and E. Now, do I have C there? Do I have C there? Sorry, do I have AC here? No. Do I have B? No. Do I have C? No. Do I have F? No. Do I have G? No. So the only attributes that I can find with A, E, and D are themselves. So this is trivial, so this is not a candidate key. Let's do now AE with, well, with E doesn't make sense because I have it here with F. So AEF takes me to AEF, so it's trivial, I'm going to write it. So AEF, do I have AC? No. Don't have AC. Do I have B? No. Do I have C? No. Do I have F? Yes, I do. I have F here. So A, E, and F takes me to, well, to B. Let me put this sorted. So F takes me to B. And then I have E and F. Let's start from the top. I still don't have AC, but now I have B. And B takes me to C and D. So A, B, C and D, now E and F. So let's start from the top again. AC takes me to H. Do I have AC? Yes, I do. AC. Now I can find H. So A, B, C, D, E, F, and AC takes me to H. H. What am I missing? I'm missing G. Anyway, let's see if we can find G in any of these. Yeah, I can find G from C. Let's see, do I have C? Yes, I do. So C gives me these three attributes, but the only one I need now is G. So A, B, C, D, E, F, G, H. And this is the relation, which means this is a candidate key. So another candidate key. Let's try A, E with G. Can take me to A, E, and G trivially. Yeah. Now, do I have AC here? No. Do I have B? No. Do I have C? No. Do I have F? No. Do I have G? Yes, I do. G takes me to F and G. So A, E, F, sorry, to F and H. F, and I'm going to put the G again here, and H. So G took me to F and H. I'm going to start from the top. I still don't have AC. Yeah. Do I have B? No. No. Do I have C? No. Do I have F? Yes, I have F now. F is here, and F takes me to B. So A, B, E, F, G, and H. Gonna go ahead and start from the top. HC is not here, so no use. Now I have B. B takes me to C and D. So I have B, so I can reach C and D. A, B, C, D, E, F, G, H. This is the relation, which means this is a candidate key. Okay? Another candidate key. Now, let me go ahead and try AE with H. That's the only one that it's missing. So I can find A, E, and H, yeah, if I'm given these. Now, let's start from here. Do I have AC? No. Do I have B? No. Do I have C? No. Do I have F? No. Do I have G? No. So the only attributes I can find using A, E, and H is themselves. So this is trivial. I cannot find the whole relation. That means that this cannot be used as a candidate key. So AE has been combined with all of the other possible attributes. Okay, and we have 4 candidate keys. So now we have the candidate keys, okay, in green, and the ones that are not candidate keys in red, okay. Although these are not candidate keys by themselves, so these 3 attributes cannot be a candidate key because through these 3 attributes I cannot find the entire relation. If I combine them with other attributes, they can become a candidate key. So let's try that with AED. AED. Let's combine it not with A, but with B. And let's see. Now we would have to take the closure of these. But if we look carefully, we will see that this key here is a superset of this key. Okay, it's a superset of already existing a candidate key, and a candidate key cannot be a superset of another candidate key. Okay, it has to be minimum. So because I have A, E, and B here, it means that this one cannot be candidate key. Okay, so let's try A, E, D with B now with C, and we have the same problem. This key obviously will find the relation because it is a superset of this candidate key. Okay, so I won't be using this either. Now A, E, D with F. Well, obviously same problem again, yeah? So here is the candidate key. And same thing with G, yeah? A, E, D, G. Here it is. A, E, and G. So I'm going to use it. Although obviously I could find the entire relation, but it cannot be a candidate key because it's not minimum. In other words, it's a superset of an already existing candidate key. Now, what about AED? Let me separate this. There's nothing to do. Okay, so AED and age. Is this a superset of any candidate key? Let's say AE and then B, D, no, and H, no. So this could be a candidate key because it's not a superset of a candidate key. So let's calculate the closure of this one. So A, E, D, H can take me to A, D, E, H. What else? So AC, I don't have AC there. I don't have B, I don't have C, I don't have F, and I don't have H. So also I cannot get the entire relation from this key. So this is not a candidate key. Now, let's do the same for AEH. Okay? AEH. So combine it with B, and as we can see, this is a candidate key, the underlined. It's already here. So this one is a superset of this candidate key. I can choose this as a candidate key. Now AEH with C, same problem. So AEC is candidate key. What about A, E, H, D? Well, it's not a superset of any of the candidate keys. But I already tested that combination right here. Yeah? It's the same AE, HD or AE, DH, same thing. So this one has been tested. Don't need to test it again. AE, H with E, F, with F. So with F, I know that already. I have a candidate key that is AEF, so this is a superset of this candidate key. So, can do it. Now, AEH with G. I mean, I think you already understood this, and I wouldn't need to be writing this one, but okay, AEG, so this is a superset of AEG, so can't be a candidate key, alright? So we combine this with all the possible attributes, we combine this one with all the possible other attributes. Now, we still have this one here. Alone, I can't get to the attributes, but if I combine this one with all the other attributes, maybe I can get a candidate key. So let's see, A, D, E, H, A, D, E, H, and I'm going to combine it with the ANO with B. Okay, so I have the same situation as before because I have A, E, and I have B. So A, E, B is already a candidate key, so this would be a superset of this candidate key. Can't use it. Now A, D, E, H, so we are doing this one, yeah. A, D, E, H with C. So A, E, C. Okay. So cannot use it because it's a superset of this one. And what about A, D, E, H with D no, with E no, with F? A, D, F. A. Oh no, sorry. AEF, yes, AEF. So this is a superset of this one. Okay, so can't use it. Let's try ADF with G. ADE H G. So it's a superset of this one. So A, E, and G. Okay, cannot use it. And I cannot combine it with any other because they are already here. So, if I now, I mean, I don't have any other possibility to combine with any other attributes. If I try to combine any of these with another one, if this is a superset of a key, of a candidate key, the one with more attributes, these attributes and more, will also be a superset of the same key. So the only candidate keys I have are these. Okay? So if these are my candidate keys, it means that my prime attributes are A. Prime attributes are attributes that are part of a key, of a candidate key. Prime attributes are A, are B, are A, B is C, D is not, E is prime attribute, F is prime attribute, G is prime attribute, H is not a prime attribute. So now, in order to see what is the normal form of this table, I need to see if there's any violation of the normal forms. So the first thing, I mean, is it in first normal form? First normal form? Well, because I don't have any data in the table, I mean, I just have the attributes, I cannot see if this is atomic. And because I cannot see if it's atomic, I have always to assume that this is in the first normal form. Okay, so it's always in first normal form. What about the second normal form? Well, second normal form deals with composite keys. Do I have composite keys? Yes. 1, 2, 3, 4. In the second normal form, I say if the table is in second normal form, I cannot reach a field by using just part of the key. Well, let's see if, for instance, from this key, I can, by using just one of the prime attributes, if I can find any of the others, the other attributes. So my key, this first one is AEB. Let's say if I use B, can I reach, if I use B alone, can I reach any other attribute? Yes, I can. So already there is a violation of the second normal form. Okay, I could also try this one from C by using just C, okay, part of the candidate key. Can I find any other attributes? Let's see. C, yes I can. So I just need C to find other attributes. So I'm using part of the key, of a composite key, to find other attributes. So there's a violation here. It means that the table or the relation, yeah, it's better, the relation is in the first normal form because, for example, the functional dependency B determines CD violates the second normal form, since I can find CD by using part of the key A, E, B. One example, yeah? There are many. I could go and see others. For example, this one, G or F, can determine. So I'm using just part of the key to find other attributes. In order to be in the second normal form, I must need the whole key to determine any of the other attributes. Okay? So I hope this helps.